Hi everybody, welcome to today's webinar called Full Steam Ahead. I'm Mare and this is Andrea and we're the MakerBot Education team. That's us. Welcome, we're so glad to have you with us. Today we're going to take you through the basics of STEAM education and incorporating STEAM in your classroom. And then we're going to walk you through the basics of 3D printing and how to incorporate 3D printing as well into your classroom. So we're really excited to have you today. So the way that it's going to work is first we're going to do a little bit of a Q&A between me and Andrea.
Right.
And then we're going to do a live demo and at the end possibly take some questions.
Great, so let's get started.
Okay, so this is just a list of the questions. At the end, you'll get a follow-up email with this deck and all of the resources that we're going to be talking to you throughout the course of the webinar.
So I think the first question, and this one's for you, Mary.
Okay.
Why STEAM?
That's a great question. STEAM education is very important in the classroom. We really believe that incorporating STEAM is integral into the classroom. And you can see by this quote here from the World Economic Forum. We like to say this all the time. 65% of children entering primary school today will ultimately end up working in completely new job types that don't even exist. And every time I hear it, it just blows me away. And that really is why incorporating STEAM is so important, because we really have to prepare our students for these future jobs that don't exist. And personally, I think that STEAM affects students in three ways. So the first way that I see it affecting the classroom is that students wind up performing greater in all content areas, not just these STEM areas, because they're learning higher order thinking skills and they're starting to think critically and they're problem solving, and this learning that occurs is really valuable across all of the things that they do in their classroom. The second thing that I really think is important is that by doing the design process in the lesson plans that you teach, which we're going to talk about later on, the students are starting to get more motivated and engaged throughout the course of the lesson. So that's really a key part of 3D printing. And the last thing is workforce preparation. So the students are learning these career-defining skills that they'll use later on in their life. So I think it's a really valuable tool that you can incorporate in your classroom.
Yeah, absolutely. And so the next question, what value does 3D printing have in education?
Sure, so on the next slide you can see that we gave you some examples of some STEAM lesson plans. These are just some lessons, and Andrew's going to talk to you later about Thingiverse Education. But these lesson plans are starting to have students think about the traditional lessons that you're working in different ways. And the next slide will show you about the design process. And so we did a webinar. With Kathy Schrock, one of our educators that went through our education process, and she introduced us to the launch cycle. And this is a quote from A.J. Giuliani, and it says, "Design thinking provides a way to think about creative work. It starts with empathy, working to really understand the problems that people are facing before attempting to come up with ideas and create solutions." And that's another thing that Andrea and I have seen throughout our time here at MakerBot, is that when you're using real-world problems and having students solve these real-world problems, they're really helping to engage them and motivate them throughout the lesson plan. And because of that, we came up with our design thinking process, which is on the next slide. And you can see here, it does start with empathy. And students will create a journal, they'll create this design document, and then they'll define the problem. So they're going to create a problem statement, and then they're going to start brainstorming and think about different possible solutions for that problem. And then they're prototype, and they'll look at it, and they'll get feedback. And this is what Andrew and I always say. This is where the real learning occurs.
Right.
Because if they fail, that's an opportunity for them to learn.
Right.
And so only by testing and reflecting on it will they start to really think and be able to go back to the drawing board, iterate, make another version, and you can see how that's the perfect fit for 3D printing.
Absolutely.
So this one's for you, Andrea.
All right.
All right. So why MakerBot? Why
MakerBot? So let me tell you. So the great thing about MakerBot is that it stands for three very important things. Providing printers that are easy to use, super quick to get set up. Also, a great 3D printing community. So if you've heard of Thingiverse, that's a great place that you can go to find things that you can print. You can find people who are also using 3D printers, especially in Thingiverse Education, that'll bring up a little later on. And then the customer service. So Mary knows this, but I used to be on the support team for 2 years. Definitely know everything about the printers, but in my time there as well, I spoke to teachers every single day. And, we really took the input that they gave us to heart. So they would tell us, maybe it'd be easier if you had this, or if you let us know ahead of time about this. It'd be a lot easier to understand if maybe you have this resource available. And so we really listened to everything that these educators had to say, and brought it to our product team, to the people designing these new printers, like the printer right behind me, to make it super easy to use, to have a really good support system, a really strong ecosystem where that educator can feel supported all throughout the process as they're learning about this technology and using it in their classroom.
Absolutely. That's great. And this is just a map here. This shows that our printers are in over 7,000 schools.
Yeah.
And so we like to brag about it.
It's a really cool fact.
So this is, I'm sure, what everybody's been dying to see. What is 3D printing? Like, we know it, we see it every day, but
Right.
for those of you out there that haven't seen it, Andrea, tell us about 3D printing. What is it?
Yeah, so 3D printing, which I absolutely love. I wish it had been around when I was in school. 3D printing is the process of taking a digital model and then making it a physical object. So for us, and since there's different types of 3D printing technologies, what we use is called FDM, or FFF. It's fused deposition modeling, and what that is, I have my little extruder here. What fused deposition modeling is when you have a material, usually a plastic, we use a PLA, and then we actually feed this PLA through the extruder, like this, and there's a little motor that's pushing the filament all the way through here. And then around this area is where it heats up to quite a lot, to 215 degrees Celsius. And that's about 429 degrees Fahrenheit. So it's really, really hot. So you definitely don't want to touch this bottom portion. But what's happening down here is that the filament is getting pushed out through this little tiny nozzle. And as it's being fed out, this extruder is moving, just like this. There's a little plate, and the extruder is just pouring film, or not pouring, extruding filament onto that little build plate, and then the build plate's just lowering slowly until you have an object like this little guy here that we'll talk about a little later on. And then if we go to the next slide, we can see kind of the overall process. So you start with a model, and this could be something that you create in Tinkercad, Fusion 360, or a file that you find on Thingiverse. So you find your file, hopefully it's designed for 3D printing, and then you take it to a software. In this case, it's a software that we call slicers. These slicers prepare your model for 3D printing. For us, we have MakerBot Print software. It's our own software. And that software is going to take, if I take this little guy again, it's going to take that 3D model, that digital model, and slice it, just like sliced bread. So you can imagine it's just going through all of it, making a bunch of layers and calculating how it's going to lay that filament out. After that, you have your file sliced and you take it to your printer and you print away.
So, I mean, that seems so easy, and it really is.
It is.
And as Andrea said, our printers are really easy to do, to operate, and we're going to show you later on how that works. But before we do, let's talk about who uses 3D printers.
Well, other than MakerBot, there's a bunch of other industries that use 3D printers. So if we go to the next slide, we can actually see all the industries that use it. So we can see here on the top left, we have engineering, manufacturing, architecture, medical. We also have design, entertainment, and then most importantly, I think, we have primary education and university. So this is a technology that can be used pretty much in any scope, in any industry. And so we've seen that a lot with education. You can find a lot of different applications for different grade subjects as well. And then if we go to the next slide, we can see.
This slide is a little bit wordy, but we like to put it in here just because there's so many different use cases out there. And Andrea and I are always reading different articles, and we come to work and they're like, did you hear about? So Andrea, what is the latest things that you've been hearing about 3D printing?
So one that I like to mention a lot, it's my favorite one, it's a 3D printed cornea. So that one's really cool. What happens is usually the wait list for a cornea transplant is about 5 to 8 years, which is a really long time, right? But now they've been able to cut that process down with 3D printing to about 3 to 5 years, so almost half the time. And it's really neat because now instead of when you get a cornea transplant, you usually use that cornea once to transplant it. But with 3D printing, you're actually able to use the material from that one cornea and use it for 50 transplants.
That's awesome.
Yeah.
I mean, you can print a cornea on our machine.
Not on this one.
However, you're teaching your young people right now the technology that they'll go out and utilize in the medical industry when they grow up and have a medical career.
Right.
This other one that you're holding, this is one of my favorites.
Yeah. Mine too. So this one is from the Enable Hand project. And so typically this one has actual, I think, rubber bands on it, right?
There's a rubber band system that makes it actual functional.
Right. And so the great thing about 3D printing is that it's really driven down the cost for prosthetics, right? It used to be very difficult, very expensive to be able to obtain a prosthetic. But now anyone that has a 3D printer, or if you have access to a 3D printer, you can find these designs on Thingiverse. You can modify them as well. And you're able to print something like this, and you can see how all the fingers here move. Super, super realistic, right?
And Andrea and I have the opportunity to teach teachers here at MakerBot all the time. And this project comes up all the time. We hear teachers coming in here telling stories about their classes, and they're designing these and then shipping them all over the world. And it's a really great way to teach digital citizenship too to students and giving back, and I really love this project.
Absolutely. So Mary, back to you.
All right.
What is the return on investment?
Great. I mean, so as I mentioned, Andrea and I teach teachers like yourselves all the time, and this question comes up in almost every workshop. And I like to break it down into 3 different age groups. So in the younger set, that elementary school K through 5, students are really starting to, get inspired by the technology. And a great thing about 3D printing is that there's something tactile. Like this lesson that we're going to be talking to you about later on, you can see they have something tangible, something that they can hold as an output of the lesson, and that really starts to get them to start thinking. They establish spatial reasoning, and it's really a great tool for that younger set. Right. And then when you get to middle school, that's where that design thinking skills and learning about iteration that we talked about earlier comes into play, and they really can start to get hands-on and actually see like the real-world applications there. And then in high school, that's where the students really thrive. So they're starting to get into it and really defining their 3D design skills, and they're starting to prepare themselves for college and for the workforce. And so it's definitely a skill that will continue on throughout their lives. And we have a great example of it. We worked with the Montclair School District, and they have printers in all the way from K through 12. And so they have printers in each one of their grade levels, and you can see the success they've had by students that start out in kindergarten and then all the way through high school. They know the technology and they're familiar with it, so it even makes it easier when a whole school district is using the same technology.
And then, so I think what's really important is success. So how can I or the teacher ensure success?
Yeah, absolutely. So this kind of stemmed out of something, another thing that we saw in classes is that a lot of teachers said, wow, we have the printer in our classroom,
Mhm.
but it sort of collects dust and
Right.
we're not able to use it. And
Yeah.
I think it's because of a couple things, but 3D printing can maybe seem intimidating at first. And so that's why, as Andrea mentioned, we want to speak to that whole ecosystem of resources.
Mhm.
And we made this sort of checklist for you so that, you can make sure that you're successful in your classroom. So first things first, make sure that if you're an administrator, you're providing these resources to teachers and that, or you yourself, you learn the things that you need to learn before you get started.
Mhm.
And we have we'll be sending you a follow-up email with links to Thingiverse Education. And
Mhm.
if you're watching right now on our website, there's a link to the MakerBot Educator's Guidebook where you can download a free PDF of that book, which Andrew will talk about later.
Yep.
Then the second step, we see this a lot. Pilot with either one or two classrooms, and if you're just using your own classroom, identify a champion. There's always this one student in your class that really picks up on the technology or is really
Right.
enthusiastic, and you can assign that as a 3D printing leader or a STEM leader in your classroom and have them be the champion for the rest of the class.
Right.
Budgeting for ongoing costs, this comes up a lot. And Andrew, you might be able to answer this coming from support. What are some
Yeah.
reoccurring costs that come?
Sure. So I think something that's important to know is that the extruder that I showed you guys earlier, this extruder is considered a consumable. So this guy is constantly heating up to very high temperatures. There's material being run through it, and so it's going to wear out over time. It does have a 6-month warranty, but it's not going to live forever. So you do have to budget for these extruders. So typically I always recommend having like a backup extruder on hand just when you buy your printer, just so that can be already budgeted. But think about these extruders cost about $200, and so think about having this in the future budget, and also filament. So we have some filament loaded on here right now, and it's about $50, and I think you can print how many phone cases with it? I think it's like, I forget, but it's a good amount. I think maybe 90,
Yeah,
80.
so I think the
But-
filament usage depends on how often you're going to print, how much
Yeah.
you're going to print, and you'll get a sense of that, I'm
Right.
sure, once you start using the lessons in your
For
classroom.
sure. And then one other thing to consider is the build plate's print surface. It's going to last you, I don't know, maybe 3 to 4 months, which is a lot better than, say, with previous printers we used to use blue painter's tape, which wore down fairly quickly. But this is going to last you about 3 to 4 months, so budget for that. I think these cost about $50 as well.
That's good to know. I mean, and we all know that in school you have to budget for things, and sometimes it takes time to go through the purchasing process. So I think it's good to know that stuff up front and ahead of time. Number 4, we say plan for physical space. Prepping for physical space, in the guidebook, there's a really great diagram that we provided for you. We have it on a cart right now, but that depends on the layout of your classroom and if it's if you have one printer or multiple printers. So just kind of planning out where it's going to be. I know that sometimes in the younger grades, the teachers say, we don't let the students operate the printer.
Right.
So then it's behind the teacher's desk per se. But in the older classes, if they're going to identify a champion,
Yeah.
maybe it's out on the shelf and the side. So you got to think about those sort of logistics there. And lastly, obtain the necessary computer software. So Andrew, you talked about MakerBot Print, but there's other design software out there that are free. Do you want to mention a couple?
Yeah, so as far as design softwares, the best one is Tinkercad. Luckily, you don't actually have to download that one, and it's absolutely free. The next step, if you feel like you're kind of wearing out Tinkercad, would be Fusion 360, which is a little bit more complex than Tinkercad, but it really lets you make a lot more things. We use a software that's similar to actually create these printers. And then if you're more kind of like the artsy, or you're in art, you can use something that we call Sculptress. And Sculptress is also free, and it's iPad or tablet friendly, which is great.
Yeah.
And it's, imagine like a ball of clay, and you're, through the computer or through that tablet, you're just manipulating that ball of clay to create something.
That sounds great for the A in STEAM.
Yes, absolutely. Can't forget about the A in STEAM.
That's great. So I think the next question is for Andrea, possibly.
Might be.
Where can I find lesson plans to use in the classroom?
So, great question. So, we have something that is called Thingiverse Education. So if you've been to Thingiverse before, we highly recommend that you go to Education. It's up at the top. You can click on that button and go to Education. But here is where you can actually find over 600 lesson plans.
We'll give ourselves a clap.
For 3D printing. So these are lesson plans that can be sorted by subject, by grade level. We have collections. We have lesson plans that we feature monthly. And so both Mare and I go through all of these lesson plans to make sure you know that they're up to par, that they are using 3D printing, that they're good for classrooms, good for libraries as well. And
they're free, right?
And they're free. Yes, this is absolutely free. So you can actually go check it out after the webinar to see the lesson plans that we have here. And so we also, when we go through these lesson plans, we also ask that they indicate whether they align to NGSS or Common Core standards. And also, a really cool thing that I'll mention a little bit more later on is that a lot of these lesson plans were actually written by our MakerBot educators, and these educators are actually our ambassadors for MakerBot. So these are awesome educators who are using 3D printing, integrating it into their curriculum, into their school, and they are also contributing to Thingiverse Education. So highly recommend that you check it out.
I think that's the great part about Thingiverse Education is that these lessons are actually being done out there in the classroom.
Yeah.
And you can see on the left side of the screen, the featured projects there. These are different lesson plans that are out there. For example, the Washington, D.C. monument was written by one of our ambassadors that Andrea just spoke about, Kevin Rinneman. And the students, they went to Washington, D.C., and they were going on a trip, and I think Kevin taught them how to use Tinkercad in
Tinkercad.
in 2 weeks.
Something like that. Yeah.
In 2 weeks, he brought them up to speed on Tinkercad, and then they picked their favorite monument, and then they designed it in Tinkercad and printed it, and then they went on their school trip and brought their monuments and took pictures in front of said monument with their 3D design, and it really motivated them to learn the software as well as get their object printed.
And I think it was cool because it also kind of tested their spatial awareness.
Okay.
They really only had photos to compare when they were making these models in Tinkercad. So then they were able to kind of compare what they created against the actual real thing. So I thought that was a pretty neat aspect.
Awesome.
And then something that's great here is I know a lot of schools are kind of Chromebook exclusive, right? Chromebooks are great, except sometimes you can't actually, or most of the time, all the time, you can't download software onto the Chromebooks, right? Because it just uses Chrome.
Right.
But something that we created here is My MakerBot. So we know that you can't actually download the MakerBot print software using the Chromebooks, but we created an alternative, and so through My MakerBot, you can access that by going to your account on MakerBot.com. You can actually upload your files. It could be files that you downloaded from Thingiverse or files that you created directly to MakerBot.com. And then if your printer is already connected, you can actually send that file directly to your printer without having to download any sort of software. So that's really great, especially in schools. Even if you don't have a Chromebook, sometimes there's a long wait time to actually get software approved and downloaded onto your computers, right? Another really cool thing about this is Tinkercad is connected to My MakerBot. So if you're creating something on Tinkercad, you can go to, I believe it's called Export. And then send to My MakerBot, and then it's going to take you to My MakerBot, and then send it to your printer.
So everything's cloud-based.
Everything's cloud-based.
Awesome.
Yep.
Okay, I think this one is also for you, Andrea. So where can I learn the skills I need to get started? So if you already have a printer and you're not using it, or if you're looking to get one, where can you learn these skills?
So this year, Mare actually worked really hard in creating the MakerBot certification program. And so this is
Look, there I am.
There's Mare. And so this program was launched, I want to say, when was it? In April. In April. And so what this is, it's I think, a really great program in certifying educators and anyone really in how to use these printers, and then it gives them kind of the first steps in how to integrate this technology into their curriculum, their classroom, how to show students about this technology. And so the first part is called MakerBot Operator. And so that can be either online or blended, and that means it's a workshop here at our actual headquarters. But through online, they actually know, or they are taught everything about the printer, particularly this guy, the Replicator Plus. They're taught how to load filament, how to look out for possible troubleshooting, the different technologies even outside of MakerBot. And they take a few quizzes, they take a couple exams, and if they pass, they get their certification in MakerBot Operator. And that pretty much means, yes, I know how to operate a MakerBot printer, I know how to speak about this technology, and I can kind of speak to it, I can teach others about it as well.
We really just wanted people to feel comfortable going into their classroom.
Yeah, absolutely. And I can say from my time in support, this is something I absolutely wish I had. Because sometimes, this technology can be a little scary at times, right? And so if we had had this tool even a couple years ago, we would have been able to say, hey, okay, we have this resource for you. Don't worry, you're going to be taken care of pretty much. You're going to know your stuff. And this one's really exciting. So ISTE Seal of Alignment. So we recently received our Seal of Alignment from ISTE, and so Mare was also a big part of that process. Do you want to speak a little bit about it?
Yeah, so as Andrea mentioned, I did help develop the program and the curriculum, but we wanted to make sure that it was vetted by an outside party. So ISTE is internationally recognized organization that they went through all of our curriculum, and they said we meet their alignments in these different areas. So the teachers that take our professional development program, they're learning how to teach leadership skills, collaboration, design, and become facilitators of the classroom. So this is where we align with ISTE, and we're really excited and proud of it.
That's great. And then after that, we also have, this is actually something that comes out from certification. So for the level 2, the curriculum creator, which is when you start to kind of find ways to integrate this technology into the classroom, we ask the educators taking this to create a print kit. And a print kit is, it shows kind of the different principles of 3D printing. So you can see in some of the photos here, particularly the one in the middle, some of them show what infill is, what supports are, rafts, and you might not know what those mean exactly quite yet. I'll show you a little bit about some of them a little later on. But it's a really neat way of being able to quickly show students what these different things in 3D printing mean and how they can affect your printer, how they can affect even your lesson plans, how you can use these principles of 3D printing to your advantage as well.
And these are actual pictures of some lessons that people that went through our level 2 certification, they submitted. And Andrea and I get so excited when we're grading everybody's assignments, and we don't remember whose lessons, but if you're watching, we love your print kits, and we're showcasing them here today.
Right.
Let's keep them coming.
And then finally, we have the MakerBot Educators program. So this is something that is definitely close to my heart. So I mentioned that we have our MakerBot Educators, the 80 ambassadors, or actually we're up to 120 now. And so, like I said, these are ambassadors who are kind of on the same mission as us, right? So they are looking to use this technology in the classroom and really show it off, kind of show how important this technology can be, how helpful it can be in with students, right, and teaching them kind of whatever subjects they're in. So these educators, which I recommend that you guys join, are kind of the driving force behind MakerBot's EDU team. And you can also apply to be a MakerBot educator. If you already have one of our MakerBot printers, we would love to have you join. The only thing you have to do is upload a lesson plan to Thingiverse Education for us to check out. If it's approved, then welcome to the team.
You get one of these shirts.
You do get one of the shirts that we're wearing. I think you'll see them a little later on. And so you get a really cool t-shirt, you get a poster, and you get a lot of really fun stickers.
Stuff.
Yeah. And we also hold monthly challenges. So through these challenges, we would be asking things like, have you seen any grants that we should be adding to our grant guide? Do you have any recommendations about how to get started, or if you see something new? And so we take everything into consideration. And we also send filament, sometimes even printers. So highly recommend to join.
Okay,
All
so
right.
that brings us to our live demo. So we're really excited about showing you one of the lesson plans from our guidebook. So today we're going to demonstrate a bit of the printing process that Andrea was talking about earlier by going through our 3D musical shapes lesson plan. And
Right.
so this one's pretty close to our heart. This is our guidebook right here. And this is a beginner level lesson plan that incorporates art and music and math. And the way that it works is, and do you remember the author of this? Andrew's going to look up the author so that we can give her credit. I think,
Of course.
I don't want to say it incorrectly, but it's,
So it's Carrie Hutner. Hey, Carrie.
hi, Carrie. And so what Carrie did was she developed this lesson plan using a software called Morphe, and it's on an iPad. So if you have an iPad, you can use it there because it's a little bit more hands-on, but there's also applications for Mac and PC as well. And what they did was they designed their musical shape on the iPad. They exported or sliced the file, as Andrea mentioned, and they printed it on the 3D printer. And we have some examples of some of the instruments here. And what it's teaching the students is when Andrea was mentioning infill, the infill she's going to show you creates different shapes within the print. And by using different shapes and different bead sizes, you're teaching the students that they make different sounds.
Right.
And so it's a really great way to interact with the students. And so
Yeah.
Andrew's going to walk you through how to set up the printer and set off a print.
Absolutely. So we're still waiting for the extruder to heat up a bit. So it needs to heat up to 215 degrees Celsius. It is quite hot, so it takes a little bit to heat up. And you can see where the filament is actually stored. So this is our filament drawer, and then the filament's routed all the way up through here, and then out. So currently we're at 165 degrees, so it's going to be just a little bit longer.
Can you talk a little bit about the extruder and how it's removable and how
Sure.
you snap it onto the printer itself?
Yeah, so the extruder is heating up right now, but what happens is, maybe if I go a little closer here, you can see that there's actually magnets on this extruder. And so it actually snaps right into place on a component here that we call the carriage. So the carriage also has magnets, and so when we place it close, the carriage is just going to snap that extruder right into place.
So that's all you need to do. And then how, I know the answer to this, but I'm just going to ask you anyways, how do you get the file to the printer? What options do you have?
Yeah, we have a couple of options. So you can connect to the printer using Wi-Fi or Ethernet. You could also use a USB cable. In this instance, we're actually using a USB jump drive or thumb drive, however it's called. And usually if we're quickly kind of on the go, we're going to use that jump drive just because it's so quick, since we're kind of walking from printer to printer. But it's super easy to use the other 3 connection methods.
Awesome. So that sound means our filament is ready to go?
Exactly. So now I'm going to take the filament here, and I'm actually touching the physical filament. And I'm going to feed the filament through the extruder. We already have one on here. So I'm just going to feed it through until I feel the extruder actually pulling the filament in. And I like to keep my hand on the filament to make sure it's getting pulled in all the way. So I can feel it getting pulled in, and it might be too far away, but you might be able to see filament starting to extrude here from the bottom. And it's really hot, so don't touch it. But now you can see that filament is actually extruding. So we're going to say, okay, filament's extruding, and it's going to stop. And
That's awesome.
yeah, and if you give it a couple seconds, we can actually take the rest of this off.
That's great.
Mm-hmm.
So the guidebook gives you a step-by-step of this lesson plan. And for this lesson, you pre-print half of the cylinder, which you can see here.
Mm-hmm.
And
And I'm actually going to take it off.
perfect.
We don't recommend doing this while you're printing.
But just for demonstration
Just for
purposes.
demonstration purposes. So you can see it's not done printing yet. Let's see if I get closer. So you can see the actual pattern right here. This is what we call the infill pattern. That's the internal support structure for the printer. so that if you squeeze your object, it's not going to crumple in your hand. So that structure inside is going to support it and keep it from actually crumpling. And so what we're going to do, something I should mention is that we're working, for this lesson plan, we're working with the z-axis. So let me show you guys. So with 3D printing, we're working in a 3D dimension. So we're using our x, y, and z axis. And so usually I make this little hand sign that helps me kind of determine which is x, y, and z. So for the x, it's going to be this one. It's going in the left and right direction. And then we have our y-axis, which is this one, and it's going in the forward and back direction. And then finally we have our z-axis, which is always going to go in the up and down direction. Exactly. And so what we're doing here is we're pausing the printer as it's lowering. We pause it. And then what Mary's going to do, we're actually going to drop in some little beads into the infill, the little crevices. And sometimes this makes a little bit of a mess, but that's okay.
Okay.
And so now, can't exactly show you, but we've added some beads to the inside of the infill of the model. We're going to slip this back in. There we go. And then we're just going to click resume. And so we'll resume. And so you can see it's going to pick up right where it left off. And so typically when you're actually doing this lesson plan, you won't take the build plate out. But when you pause the printer, the build plate will lower all the way down, and it'll give you enough space to actually go in and throw in those little beads. Mm-hmm.
Right. Well, we're just going to pause it right now for the rest of the webinar.
Right, just because it can get a little bit noisy. But once the print completes, this is an example of it, the little beads will be stuck inside of the model. So it'll be printed inside. And then you're kind of left with these little musical shapes. So this one, lovely little maracas as well.
And we have another
shape
here. So
yeah.
You have all these different options of creating shapes and putting shapes together, and you're really learning solid modeling here.
Yeah, absolutely. And like Mara said, having different sort of infill percentages, that means either having more infill or less infill, can change kind of the sound that these musical objects make. Awesome, right? Yeah. And then, so I think
that's all for the demo. We also have Allison with us from our team, and she's been monitoring and
moderating
our webinar
here.
So we do have YouTube Live going on as well. So if you're joining us through YouTube Live, you might see a chat window, and potentially we have some questions from there as well.
Yeah, absolutely. So the first question is one that we actually have a slide pre-prepared for.
Okay.
Where do I get the guidebook?
Oh, okay.
Yeah.
Oh, great.
And also, what is the guidebook?
Oh,
the
sure.
guidebook. Okay, so here's the guidebook. And if you're watching us from MakerBot.com, you'll actually see there's a little download button down below where you can click to download it, and you'll get the PDF version of it. But, so what is the MakerBot Educator's Guidebook? So the MakerBot Educator's Guidebook is split into 3 sections. So the first section is it's a crash course in 3D printing. So it tells you kind of what infill is, like we talked about, what a slicer is, so MakerBot Print, what is 3D printing, pretty much all the different elements of 3D printing. And then in the middle, which is kind of the real meat of the book, there are 9 fully fleshed out lesson plans. And so one of the lesson plans is, of course, little musical shapes. And I think we actually have another one here.
Yeah.
This is another one of our lesson plans. I think it's the first one, right?
This is the first one. So the lessons go in order from easiest to hardest. So if you do download it, the first lesson's a great place to start out.
Right, yeah, absolutely. And so the great thing about these lesson plans is that they have everything that you need, right? Absolutely everything that you need. So it has the objectives, it has the standards, it has the steps. Even if you're not familiar with the design software quite yet, it lists out the steps for you.
Yeah.
It also tells you kind of the prep time, so how much filament you're going to be using, the amount of time it's going to take, if you need to print something beforehand as well. So it's really great if you have that printer, maybe it's collecting dust, maybe you just received a printer. You can choose one of these lesson plans. You can tailor it to fit your style in your classroom and use it right away.
Yeah, and the education team, along with myself, we co-wrote the book about, I guess, 2 years ago, and with people like Carrie and Danielle, who did the clouds lesson, and all of our educators helped give us the feedback so that we made sure we made a solid lesson that had everything that you would possibly need to have a successful classroom experience.
Right, absolutely.
Cool. The next question is there any specific design software I need to get started?
Well, I mean,
That's a great question.
yeah, I think if you're absolutely starting off, if you've never used any sort of 3D design before, I think the best place to start off with is Tinkercad, of course. That's, I think, really what we think. It's super easy to use.
They have great tutorials on their website.
They have a lot of easy to use tutorials, easy to follow.
Yes.
And it's, the way I like to say, it's like working with Lego blocks, but it's just in the computer instead. So you're moving, you're dropping little, it can be cylinders or cubes onto a little work surface and building something. And then over time, as you get more comfortable, you can maybe start creating something that's more complex. But that Tinkercad is, I think, the best way.
And also in the guidebook, there's a section that we have kind of listed out for you, some recommended software, and whether it's free. There's lots of software out there that if you're an educator, it's free for educators, and then some paid software and different skill sets that it will help you with. So I would recommend you check that out too.
Yeah, definitely.
Cool. I have a lot of people doing shout-outs from Latin America.
Yay!
And they're wondering if there's any progress on moving towards like STEAM or like bringing in more education resources for Latin America.
Yeah, so I am all about it as I'm Mexican, but what we do have someone in Mexico right now that has a team, and they have actually kind of translated this book. It's available in Spanish as well, and I think certification is on its way, or?
Yeah, so I've been working with some of our trusted resellers from Latin America, and we've done some of the video translations, so captioning in Portuguese, so that may be available, different of our videos captioned in other languages. So possibly certification.
Yeah.
Not going to commit to it right now.
Right, but I think that's something that we will be seeing eventually.
Yeah, absolutely. We want to expand and make these resources open to as many people as possible.
Absolutely. And then Mir mentioned some resellers. So we do also have resellers that have written lesson plans in Spanish. So in Thingiverse, you can find lesson plans that are written in Spanish, I think in French as well, German. There's a variety. But it is something that we are kind of working towards to provide more resources to LATAM.
Cool. Is this lesson or lessons like it on Thingiverse Education?
Yes, absolutely.
All of the lessons.
Right. So all of the lesson plans in the MakerBot Educator's Guidebook are available on Thingiverse. You can find all of them on there.
And what that also means is that the files are there. So if you're not familiar with Thingiverse, not only is the lesson plan there, but the files themselves. So if you're just starting out and you want to practice, you can download the files and just practice printing them before you even get into the design aspects of it.
Right.
So that's also a great way to start if you're not comfortable with your design software yet.
Right.
Cool. The next question is, how much does certification cost? Where do you get it? There's a lot of stuff.
Okay. I'll take that one. So, as Andrew mentioned earlier, certification comes in two different formats. So there's a fully online program that costs $99, and there's a blended workshop, which is a hybrid of the online and an in-person training, which is $199. And you can go to makerbot.com/certification to learn more about the program, and it's available through purchase either on our store, our online store, or through your reseller. There's special bundles that we have out right now, so look out for those, that if you buy a certain amount of printers, that you can get certification for free. So we highly recommend you do that.
Yeah.
Cool. I have a great question of what are some of your favorite 3D projects? And I'd say, let's say, favorite lesson plan that you've done.
Oh, man.
I know.
That's a tough one to be put on the spot for.
Shoot. So today, speaking of LATAM, today is Day of the Dead, Dia de los Muertos, and so there's actually a lesson plan that was created for Day of the Dead, which is where you create the designs on a skull, well, a skull that you find on Thingiverse. And so you 3D print these designs, and you actually have students learn about Day of the Dead, about world history as well. And they get to create their own sort of sugar skull as well. So that's one of my favorites.
That's awesome.
Yeah.
I really like that one as well. We see a lot of different lesson plans. So my favorites are the ones that resonate from my childhood. So any lesson plan that is a recreation of something that I did in like 3rd grade, I go crazy for. So I've seen people recreate the traditional volcano lesson where you make a paper mache. So instead of using paper mache, they're 3D printing. I've seen the CO2 car lesson plans, lots of those. So any of those types of the old rocket ship when you were in when we were in elementary school and you built a rocket. Well, now instead of building it physically, you can design it, and there's some really great like lesson plans that I've seen in collaboration with NASA. One of our educators, he did a lesson plan where you went on NASA's website, you designed a piece for the bottom of the rocket, and then he would have the students design it and fit it for their the STLs that were on his site. So very cool stuff.
Will there be any webinars on modeling?
That is hopefully in the works.
It's in the works.
Right, that's definitely something that we want to provide. We do make 3D printers, and we do love to talk about design software, and so that's maybe not our expertise, although I think both of us are pretty good at design at this point. But hopefully in the future that is something that we can provide, so you can kind of be ready to do something before you actually 3D print.
I think that was our major piece of feedback Andrea talked about. We love feedback, so we love to hear from you. We hear from our ambassadors. We've heard from our certified educators that the thing they want more of is design.
Right.
So keep a lookout for some future design certification courses.
Awesome. I also have a question. Somebody is working on the MakerBot Educators program, and they have questions about their lesson plan. How do people reach out to you?
Sure.
Yeah, so great question. So they can actually, if they have any questions about the submission process, it is changing a little bit in the coming months. They can reach out to us. We'll be sending an email to them after this webinar, and if they have a question about the approval process, about joining MakerBot Education, then they can respond back to that email. We'll be able to check it out. Give us a couple days to reply back. But we will be able to see kind of any questions that you have. If you have questions about the lesson plan, how do you actually submit it on Thingiverse Education, because it can be a little tricky the first time around. Make sure you're checking that checkbox for education.
The guidebook has a step-by-step also.
Oh, perfect. Guidebook also. So if you're downloading that, be sure to check it in the guidebook, and it'll be able to walk you through the process.
I'm gonna get some more technical questions for you.
Bring it.
The first one is a low ball. Can you print multiple items at the same time, and if so, how?
Oh,
Absolutely. So here, this guy. Toss those little beads. So you can actually, in the MakerBot print software, you'll see that there's a virtual bill plate in the software. You can actually insert multiple models on that virtual bill plate. So say you want to print 2 cylinders,
these were actually
2 drumsticks.
These were actually sliced together.
Oh, right. These 2 were printed together, and so you can have them like that on that virtual platform, on that virtual bill plate, and then actually slice it through the MakerBot print software. And the software will just treat it as part of one file. It'll just say, okay, here's where I need to extrude filament, here, 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 and here. It'll just treat it as one file, but at the end of it, once it's done printing, you'll actually have your 4 files. And this is great also for classes because, absolutely, because you're going to have a lot of students. You're not just going to have one student, one model, right? So you can actually place multiple students' projects on that bill plate to print at the same time to save you some time.
So cool. This sounds like it needs to be like a full webinar in and of itself, but just quickly, do you have any good tips for how to take care of your printer moving forward?
I think this is for Andrea,
this is
for
for
sure.
me.
Yeah.
So yeah, definitely we want to take care of our printer, and Allison's right, this could be a full webinar. Through the certification program, through the workshops, through the blended, Mara and I run these workshops, and I always go through the troubleshooting.
Yes.
Just because, I mean, coming from support, you know exactly where things can go wrong, and you want to avoid that, right?
Yeah.
And so taking care of your extruder, I won't go into too much detail, but if you have a smart extruder already, use these 2 pinch tabs.
That's a great
These,
tip.
yeah, these will help you when you're loading
It
filament.
changed my life.
It changed your life,
Yes.
yeah. This can improve and extend the lifespan of your extruder, but just pinch those 2 tabs when you're loading or unloading filament, or if you're having an issue loading filament, like if there's like a jam or something like that, use those 2 pinch tabs.
Cool.
One other thing is the filament. I know in schools usually we
Yep.
break for the summer, right?
Yep.
And this filament, it's PLA, it can absorb moisture. So what we want to do in the summer is we want to keep those plastic bags that those spools of filament come in. And if we're leaving for a good amount of time, if you think that the AC is going to be turned off, put those spools in their little baggies to avoid any moisture being absorbed.
They have the little silica gels in there. Keep those, store them up.
Yeah, absolutely.
Awesome. Those are great tips. And I do hear that there are people saying, please do a webinar on this, so
I'd be happy to.
we will
Yes.
make a note.
All right, noted.
Is it safe to leave a project paused overnight, or is there a way to resume projects when it's turned off?
Good question. So sometimes we have prints that are going to take a long time to print. So actually, Mara, if you want to hand me that nice little MakerBot certification
Yes.
print. This one I think took about 40 hours to print, and it was in a slightly larger printer. And so of course, you know, we don't always want to leave our prints or our printers printing through the night, because if something goes wrong, we might not be able to catch it. The printer has ways set up to pause the print if it feels like something's going wrong, but it's not going to be able to catch everything, right? So we can pause our print overnight, and usually it's fine. But if you feel like your school or your environment has a lot of sort of power failures, or you see the power going down, it might not be the best bet if you have a very long print.
You can also monitor your prints on MakerBot Mobile or My MakerBot. There's
Right.
a live camera feed, so
Yeah, so
there's lots of times I'm home checking my prints.
right, through your phone. It's a
Yeah,
really cool tool.
Do you have any lessons that you guys like for high school or for that age group?
Definitely, as I mentioned, the lessons in the guidebook go from beginning to beginner to advanced, and I'll give a shout out to our former team member Drew, who did an Archimedes screw lesson, and that is the last lesson in the guidebook, and it really is a great engineering, math, science lesson, so a little bit of history, talking